Hey guys, what's happening? So here's what we're gonna go through today. This is called limiting reagent. It's like stoichiometry, but twice. It's a great time. So essentially, what we're doing is determining which reactant will make the least amount of product. It should be done if masses of two reactants are listed, as you can see right here. So when you see like two reactants, like um, two masses listed, then you need to do stoichiometry twice. I sort of talked about this with some of you. If you're talking about making cookies and you have like 6 dozen eggs and only 1 cup of sugar, the 1 cup of sugar is going to dictate how many egg or how many cookies you can make. The eggs we have plenty of. And so the way that this is going to work is if we start looking at this little thing right here, like what mass of CO2 is made from 58 grams of butane and 128 grams of O2. So it's our little example right here. All right, you can see right there. First things first, we got to balance the equation. Butane, here's butane, there's O2. When we balance the equation, we're going to get 2, 8, 10, and what do we get over here? There you go. We get 2, we get 8, that's 16. 10 is 26, we get 13 right there. All right, so you got to balance the equation first. Obviously, this is made for when we were in class. We're going to find the mass of CO2 with one reactant. So you can see I've done everything in one line. I picked butane first simply because it was written first. There's no other reason. So I'm going to 58 grams of butane. 58 grams is the molar mass of butane. 8 moles of butane over 8 moles of CO2 over 2 moles of butane. 44 grams per CO2, 1 mole of CO2. So we get 176 grams of CO2. This is the stoichiometry we've been doing. There's nothing different. It's 7.2 assignment. It's the same thing. Then we're going to do the same thing, but we're going to do it with oxygen this time. So you can see I got 128 grams of O2, 32 grams is the molar mass of O2. There's 8 moles of CO2 for 13 grams of oxygen, 44 grams of CO2 per 1 mole, and we get 108 grams of CO2. All right. We're going to determine which reactant made the least. And the reason we're doing this is because I do not have enough oxygen. See, this is my mass of oxygen to make 176 grams of CO2. I don't have enough. I don't have enough. The maximum that we can make is 108 grams of CO2, which makes oxygen, O2, the limiting reagent. Okay? So there's no limiter. That's called the limiting reagent. There's a practice handout, which we're going to talk about in a minute. Percent yield is just the comparison between amount you made and amount was supposed to be made. It's expectations versus reality. How much were you supposed to make? How much did you actually make? We call that theoretical is what your expectations are. Your actual is what you actually did. All right. So this is all related to that example we did above. Remember, these notes are on Canvas, so you can go through and look at them. We were supposed to make 108 grams of CO2. That's our theoretical amount. In a perfect world, that's the amount of CO2 that's made. So my question is, what is the percent yield if 95 grams of CO2, this is a very key word there, right there. You see it? Right there. Is actually made. So the percent yield is actual over theoretical times 100. Our actual is on top right there. That's 95 grams of CO2. Versus what we theoretically were supposed to make. That's the 108 grams of CO2. 95 divided by 100 times, or 95 divided by 108 times 100 is 88%. So our percent yield would be 88%. Please look through this. All right. These are the notes. You can look at them anytime. This is going to show you our steps in order to determine 1, limiting reactant, and 2, percent yield.